Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 6.6 right triangle similarity. Well, what does that mean we'll be doing? It means that in this lesson, you will be able to find the geometric mean, x, of two numbers, a and b, and recognize the geometric mean as it applies to similar right triangles. Ugh, that sounds so complicated.
It really does. I'm a little scared.
Actually, it's not that bad.
All right.
Here's why. So, by understanding the relationship that exists when an altitude, that's the height of something,
Okay.
is drawn to the hypotenuse, the long side of a right triangle, will allow us to prove the right triangle altitude theorem.
All right.
Yeah, we're still sounding complicated.
We are.
Okay, well, here's the deal. You will know that you've got this mastered when you can set up proportions correctly to determine a geometric mean. Basically, what we are going to be doing is we're going to have three triangles. And we need to be able to show how those three triangles are similar and find the missing values of different parts of those triangles. And all three of these triangles kind of set inside of each other.
I will say, at first glance, this is going to look difficult, but I think it's very procedural. Once you do one, you can do them all. Like, there's one way to do these.
Yeah.
So I think that you guys are actually going to like this lesson. It's, again, very procedural.
And again, the geometric mean. Basically, the mean is when you're finding a middle or an average of something. A geometric mean just means we're going to not just divide, we're also going to be doing some multiplying. So let's go ahead and define geometric mean.
So a geometric mean is an average where we multiply the numbers together, and then we take the square root of those two numbers, or cube root if we're doing three numbers. So let's go ahead and do one. So find the geometric mean between, why am I not moving? Between 9 and 81. So the first thing we would do is we would multiply 9 times 81. 9 times 81 is 729. Well, then I would simply take the square root of it. Square root of 721 is plus or minus 27, which in this case would be a positive 27, because in geometry we only really usually care about those positives.
Now, one thing you need to remember with geometric mean, and we didn't show it really right here, is that we are just setting up a proportion and taking our cross products. So really all we did here was we said that x over 9 was equal to 81 over x. And then we took our cross products, and that's how we got the x squared equals 9 times 81. And we've been doing proportions for a while now, I think we should be okay.
So why don't you guys go ahead and do the next one. Find the geometric mean between 6 and 24. Hopefully you guys got the geometric mean is 12. And ultimately today, that is what we're doing. We didn't mention this at the beginning. Go ahead and pause the video and get out your compass and straight edge. We're going to do a little constructing in this problem. Yay!
We're going to construct an altitude. And this is not that difficult. There's a couple of things that we need to remember here. Some of us know how to construct an altitude using a compass, and some of us know how to construct an altitude by using a straight edge, and using that straight edge to find the height of the triangle from the different sides.
I'm going to go ahead and use the compass and straight edge. The construction, no matter what, you guys need to know what an altitude is. An altitude is going to be the height of something. If DE is the bottom, then I'm going to measure from DE to F, because F is the highest point. The construction that you were taught back in chapter 4 was then from point F, go across DE and draw an arc that intersects DE twice. And then from the two intersections, you're going to draw your two congruent arcs. So one, I might have made it too small. Nope, I didn't. And two. And then from here, you're just going to connect through F and through that point of intersection, and the angle that is formed should be a right angle. All right, so this is the altitude you guys should have gotten, and by doing this, what we now have are 3 right triangles. So we have our original right triangle, which was triangle DFE.
That's the big one.
The biggest one. And then the altitude is making this little tiny one here, and also this medium-sized one. So we now have 3 right triangles in this picture, and they are all similar to each other.
It's almost like the 3 bears.
It is. That's what I always think of when I teach this lesson.
Goldilocks and the 3 triangles.
Uh-huh.
All right, well, here we go.
So angle ELF. Angle oh, where did L come from? I forgot to label my point. Son of a gun. Okay, right here. You were instructed to make that L, so hopefully you followed my instructions better than I did. So angle ELF right here, so here's E to L to F. What angle do we know that is equal to?
Well, isn't that a perpendicular line? Because
that's what an altitude is.
An altitude?
Yep. Yeah. So we know that that has to be, by definition, a 90-degree angle, or a right angle.
Yeah.
Well, we also were given that angle EFD is a right angle. So why do we know they're congruent?
Because all right angles are congruent.
All right angles are congruent. Why would angle E be congruent to itself? Well, when anything is congruent to itself,
must be reflexive.
It's reflexive. And the reason we're using that, notice that I have pink and blue here. Well, because I have pink and blue there,
2 triangles share that same angle.
2 triangles share that same angle, exactly. Go ahead and color coordinate. So if you remember from a few lessons ago, if you have 2 congruent angles in 2 triangles, the triangles can be similar by angle-angle similarity.
Very cool.
So now let's go ahead and look at the next pair. So now I'm looking at angle DLF. Well, DLF is right here. Well, once again, this is the base and the altitude, which we know are perpendicular. So therefore, we know it is a right angle. And then angle DFE, well, DFE is from that original triangle, which we know is a right angle as well. So because we have 2 right angles, we know that they are congruent because all right angles are congruent. If you look over here, angle D in the green triangle and angle D in the pink triangle are exactly the same, so why would angle D be congruent to itself?
This is another sharing situation.
So once again,
must be reflexive.
It is reflexive property. And then hopefully you're seeing the pattern that's occurring here. You have 2 triangles with 2 pairs of congruent angles, so we can say they are similar by
angle similarity.
Angle similarity. And then lastly, why would angle ELF be congruent to FLD? Well, or not congruent, similar. Why can we say that? Well, look at everything we've said. I ask you to look at line C and look at line F. We have 2 different triangles similar to the same triangle. So when you have 2 different things equal to the same thing, we can say those 2 different things are equal by what property?
Transitive property?
You are correct, Mrs. Nets. All right, so the reason we went through this is we want you to see that the hypotenuses in all 3 of these are proportional to the longer legs in all 3 of these, which are proportional to the shorter legs in all 3 of these. So they are all proportional to each other. So it's going to be very easy to set up your proportions, hopefully, and work through them. All right, so the leg rule on the back side of your notes. Each leg of the original right triangle is the geometric mean between the hypotenuse and a part of the hypotenuse next to the leg. So the part of the hypotenuse next to the leg. So we kind of have the illustration here to show what we're talking about. If we're referring to this leg, well, the part of the hypotenuse that is right by it is that piece right there.
Looks like glasses.
It looks just like glasses. Over here, if we're talking about this leg, well, now we're talking about that part.
Hey, it's glasses
There's your
again.
glasses. So if you remember back to the geometric mean part, the leg is the geometric mean, so it's what's going to appear twice. So you have your leg here and your leg here. You're going to multiply that, or I'm sorry, equal that to the hypotenuse and the part. So leg to hypotenuse would be equal to part to leg. Leg to hypotenuse is equal to part to leg. And when you cross multiply this, leg times leg would be
Leg squared.
leg squared. And that's going to equal that whatever the hypotenuse times the part is. So when I said procedural, that's when you're using the leg of the original large right triangle, this is exactly how you're going to set it up every single time.
Now, you'll understand this a little bit better once we get talking about the altitude rule, but one of the things that I tell my students to help remember the leg rule is anytime you draw those little glasses, you need them to see the whole hypotenuse.
You need them to see using their glasses.
You need the glasses if you're going to see the whole thing. Now, let's talk about the altitude rule.
The altitude rule is going to be very similar to the leg rule. It's going to be obvious, I think, which one you're going to use. We'll either give you the leg here, the leg here. If we don't give you either of those legs, you're probably going to use the altitude rule. The altitude rule states that the altitude to the hypotenuse of the original right triangle, so that would be this, the one that you constructed earlier in the lesson, that is going to be the geometric mean between the segments the altitude splits the hypotenuse into. So you can see here that if I intersect the hypotenuse right here, it's splitting into this left segment and this right segment. So the altitude is the geometric mean between the left piece and the right piece.
So we have this inside number, and that inside number that has been given to us is on our altitude, which breaks apart this hypotenuse. So think of it like this. We're working with this inside thing that cut apart the big outside thing, cut it into parts. Don't need glasses because you're not going to see the whole thing.
You're not using the whole thing because you don't need to see it. So you have your altitude in two places because it is the geometric mean, and you're just multiplying those pieces, the left and the right. So altitude times altitude is altitude squared, and then it's going to equal whatever the left times the right side. So we know that this seems a bit confusing, so rather than giving you an example to do, we're going to actually, this is not on your notes, you're just going to watch us do it, and hopefully it'll be enough just watching and absorbing it to let you guys go ahead and try that first example. So looking here, here's our legs and our altitude. Those are the three pieces you're always going to look at. And in looking at those three pieces, hopefully you're seeing that you have X right here, which is on the leg. So this is going to be a leg rule problem. From here, you're going to simply set it up. So remember, so because this is going to be a leg theorem problem, we need to make our glasses to see the entire hypotenuse. So here's our leg, here's our piece. Our entire hypotenuse, now that I can see it, is going to be 6 plus 2, which is 8. So now I can go ahead and set up our proportion. X, the leg, is our geometric mean between the hypotenuse and the piece. So you're going to set this up as X written in our two places, and then our 6 and 8 in the other two. So X to 8 is the same as 6 to X. Or you can think of it as the geometric mean is the squared piece equal to 8 times 6. To solve this from here, you are going to multiply the 8 times 6. From here, to solve x squared, you have to find the square root. Well, the square root of 48 does not work perfectly. It is going to simplify to plus or minus 4 square root 3, which, because we're talking about an actual length of something, remember, it's just going to be that 4 root 3. If you need a little refresher on how I got that, I'll do it on this one here. we're going to prime factor that 48. Our smallest prime factor that goes into that is 2, 24 times, 2, 12 times, 2, 6 times, and 2, 3 times. If you're looking for pairs, you have 2 pairs of 2's, so 2 times 2 gives me that 4 on the outside. This 3 has no pair, so it stays on the inside, giving me 4 root 3 for my final answer. So that is the process for the leg rule, which brings us to the example on your notes. I would love it if you paused and attempted this yourself.
I think maybe this one we should do with them.
You think?
Well, yeah, because if you think about it, the last one they really just watched us. They didn't take any notes, so they don't have anything to refer to in case they get lost.
All right.
Sorry, just trying to help a kid out.
All right.
All right, so here we go. Not a big deal. First of all, you see we have an X on the outside, and we have 2 numbers on the outside. So looks like we're going to be needing some glasses to see across this triangle. So go ahead and get your glasses on, and here we go. So we know that X is to 8 as 13, which is the entire hypotenuse. Remember, we have our glasses on so we could see the whole thing. So 13 is to X. So I have X over 8 equals 13 over X. Or you could have X over 13 equals 8 over X. There's so many different ways, well actually 4 different ways you could set this up, and we would all be right.
Because no matter what, when you cross multiply, everybody should be getting X squared is equal to 13 times 8.
Which is X squared equals 104. Now what we're going to do is we're going to take the square root of both sides to get rid of that exponent, and we are going to get that X is equal to plus or minus 2 radical 26. Now, initially, you should have gotten that X is equal to the square root of 104. Don't forget to simplify. So, if you need that one more time, 104 divided by 2 is 52. 52 divided by 2 is 26. 26 divided by 2 is 13. And we're stuck like a prime Weichel birthday.
There we go. So 2 times 2 is 4. Square root of 4 is 2. So that's our pair that goes outside. This 2 has no pair. This 13 has no pair. Multiply them back together, you get 26. So 2 square root 26 is your answer. All right. We have another watch and listen. Notice this time when I highlight the 3 pieces up here, this time we have nothing on the legs, but we do have something on the altitude. So this is going to be an altitude rule problem. If you remember, the altitude is the geometric mean between the pieces the hypotenuse is broken into, so that left and right side. So you're looking just at these pieces right here. You have the 20 and the 5. So you're going to set this up as x to 20 is equal to 5 to x, or anything equal to that. If you write it a little differently, that's okay, as long as you end up getting that x squared is equal to 20 times 5. You're just multiplying these pieces together. Well, 20 times 5 is 100, so we're doing a nice easy one because now you're just going to square root that, and the square root of 100 is 10. The plus or minus, I'm just adding that in to help out our Algebra 2 teachers, because remember, after this class, you do move on to Algebra 2 where you need to remember that plus or minus relationship, even though most of the time in this class it is just the positive answer.
Because we're looking at distance typically, or length, or a measurement, and we don't measure
Negative distances.
negative distances.
Nope. All right, you guys have one left. Again, looking, there's nothing on that leg. Nothing on that leg, but we do have something on the hypotenuse, I'm sorry, on the altitude. So our altitude is going to be the altitude rule here, which means the altitude is the geometric mean between the pieces the hypotenuse is broken into. So you should end up getting that x is in the 2 places in your proportion, and then 6 and 4 are in the other 2 locations, something like this. X to 6 is equal to 4 to x, which cross multiplies to x squared is equal to 6 times 4, which is 24. From here, you are going to take the square root of both sides, And the square root of 24 is not a perfect number, so you are going to need to do that prime factoring. When you prime factor, you should be able to take a pair of 2's out, and a 2 and 3 stays inside, and a 2 times 3 gives me that 6. Because we're talking about the length of the altitude, we really just care about the positive answer.
2 radical 6.
And that is the conclusion of our lesson. And the conclusion of chapter 6. Woohoo!
Yay!
So, I promise, while again, initially this may seem a little confusing, it is very procedural, as I said earlier in the lesson. You are doing the same thing for leg rule and the same thing for altitude rule every single time. So, hopefully you're going to end up by green the more you do these. If not, you know how to reach us by now.
Hey, Mrs. Weigel.
Hey, what is that?
So, do you know what the name is for a fighting style that involves fractions?
I have no idea.
The partial arts. Dumb.
Very dumb. That's so funny. All right, thanks for joining us in our similarity unit. Our next unit is actually my favorite, trigonometry.
Chapter 7, the study of triangles.
We'll see you then.